This evening we've come together to talk about the issue, the earth in time and space. You know that the world out there teaches that everything is millions and millions and millions of years old, and the evidence is presented as irrefutable. And one wonders whether there is another side to the story. So I want to talk about this issue and present some thoughts to you. And as I have said earlier in our greeting, I do not wish to indoctrinate anyone. I would just like to state the other side of the story so that at least people have a choice to make. In the media, in the schools, in the university systems, in the libraries, wherever one goes, one is subjected to only one form of information. And that's not fair. Both sides should be available so that people can make informed choices. The Bible says in Isaiah chapter 40, verse 22, He sits enthroned above the circle of the earth, and its people are like grasshoppers. He stretches out the heavens like a canopy and spreads them out like a tent to live in. So obviously there's a reference there to the God of the Bible having formed these heavenly bodies. In a strange sort of way, science actually acknowledges a deity sometimes, because here is a nebula which is termed the Eye of God, one of the NASA Hubble telescope pictures. In actual fact, we are told that we are a rather insignificant planet in a rather insignificant solar system, in a rather insignificant galaxy, floating somewhere on the edge in an insignificant position of a rather gigantic universe. And probably there is a lot of truth in that. If you take one star, Betelgeuse, for example, in the constellation of Orion, then you'll see that that is an enormous star, because that over there is the size of our sun, including the entire orbit of the Earth. And that is the size it would be if it included even the orbit of Jupiter. So really, this is an enormous star compared to ours. So ours is really a very tiny object. The science literature will tell us how everything came into being, how the planets formed, how the early Earth formed out of particles and dust that coagulated. And one of the most prominent theories today is, of course, the Big Bang theory. So this theory tries to give a naturalistic view on the origin of things. And contrasting this, you have the idea that God created all things at some time in the past. Now, this is a very fascinating study, and one would like to say something more about it. Well, you see, the idea is that at some stage, everything that we see in the universe out there was concentrated in one particular point. And then at some stage, whatever was there exploded and shot out into a vast universe, expanding at breathtaking speed. And we see that this universe today is still expanding. And what they do is they look at the light that comes from distant objects, and they notice what is called a red shift. Now, when waves are stretched and become longer, that is called a red shift. If waves are compressed, light waves, and you see a shorter spectrum, well, then what you see is a blue shift, because the shorter wavelengths tend to give a blue tinge, the longer wavelengths will tend towards the red shift. Now, because everything seems to be red shifted, the idea is that the waves must be stretched because the objects are moving away from us. So the universe is expanding. Now, if the universe is expanding, then it's easy to extrapolate backwards and to say, well, if it's expanding now, that means it must have been closer together in the past. And if it was closer together in the past, well, is it conceivable that it perhaps was so close together that everything was concentrated on one point? That's the basis of the Big Bang theory. Now, I'd also like to point out that there are approximately 125,000 million galaxies, each with some 200,000 million plus suns, and the distances are so vast that we cannot even imagine them in every single direction. So really, it seems as if we are a tiny, insignificant spot somewhere lost in space. Now, the story about this redshift and all these issues in space is very interesting. Psalms 8, verse 3, 4, and 9 says, "When I consider thy heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him? O Lord, our Lord, how excellent is thy name in all the earth." So the heavens are supposed to tell us something about the magnificence of God, according to the Scriptures. Now, if you look out there into space, you will see huge concentrations of stars. And this is basically a problem. You see, if the universe was at any stage contracted onto an infinitesimal point, and it then exploded, poof, and spread out into the vastness of space, then you would expect that this matter would be uniformly distributed. This is called the cosmological principle. Uniform distribution of all that there exists in this vast universe. But you don't see that. In actual fact, what you see is a concentration of material in clusters and groups in various places. Also, what you see is spiraling galaxies, huge galaxies and super galaxies clustered together, spiraling around each other. And you would not expect that. You would expect a uniform distribution of matter. In actual fact, you wouldn't expect anything. Because if there was an explosion of first energy, which later materialized into matter, there would be equal quantities of matter and antimatter, which would destroy each other. And so basically a universe should consist only of energy, if there was ever such an occurrence. But of course it doesn't. There is a tremendous propensity of matter and not antimatter. Nehemiah chapter 9 verse 6 says, "You alone are the Lord. You made the heavens, even the highest heavens and all the starry host, the seas and all that is in them. You give life to everything, and the multitudes of heaven worship you." This is in total contrast to a naturalistic idea of origins. Now, so according to the Big Bang Theory, the universe was created between 10 and 20 billion years ago from the random cosmic explosion. That's the basic idea. And Alan Guth and Steinhardt in Scientific American in 1984 wrote, "The observable universe could have evolved from an infinitesimal region," that means a dot, maybe smaller than a dot, maybe some conjecture smaller than the size of an atom. It is then tempting to go one step further and speculate that the entire universe evolved from literally nothing. That's rather interesting. This is a scientific statement made by scientists in a scientific journal. And the idea seems to be that everything was concentrated in a dot, exploded, and this explosion came from nothing and created everything. So the philosophical assumptions you have to deal with are, firstly, a general relativity and the cosmological principle. And that basically says that everything should be spread out evenly if ever anything did materialize, but it's not the case. We see everything concentrated in clusters, and this is problematic. As the professor of astrophysics at Nottingham University admits, we're lost. The foundations of the Big Bang model would crumble away. We'd be left with no explanation for the Big Bang or galaxy formation or the distribution of galaxies in the universe. So there are scientists who are saying, why is this matter not uniformly distributed? And then there's another problem. The Big Bang also violates the law of conservation of angular momentum. Now let me explain that. You see, everything is turning around. When you look at our solar system, the planets are moving around the stars, the moons are moving around the planets, everything is moving in circles. Now, if there was an explosion sometime in the past from a center, and this explosion went poof in every single direction, then whatever shot out from there shot out in straight lines in every single direction. But that's not what we see. You see, we see angular momentum, not linear momentum. We see everything going round and round and round and round. So now the question is, how come it's going round and round instead of the other way around? The fact of the matter, it is going round and round and round. So the idea then came to mind, well, there is one possibility that could explain why everything is going round and round. Maybe that original dot was also going round and round. Does that make sense? Now, if you can imagine a bunch of kids sitting on one of those merry-go-round things in a fun park, and this thing is going round and 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 round at speed. If that thing happened to go so fast that the kids later hang on and centrifuge to the outside, and then goes so fast that the kids actually lose their hold and go flying off, then the law of the maintenance of angular momentum says that they will be spinning while they fly off in the same direction as the object was spinning originally. So if it was going clockwise, then they will spin off clockwise. Does that make sense? So that can explain why everything is going round and round. Because maybe originally the dot went round and round. And yes, everything is going round and round, and that needs to be explained. And wherever you look in this vast space, you'll find things going round and round. And as science has said, they will be flying off in all the various directions. Amos 5 verse 8 says, "Seek him that makes the Pleiades and Orion." It's interesting that it names these two star systems. And the Pleiades, or the Seven Sisters, is what is known as a bound cluster. That's very fascinating. Can you bind the chains of Pleiades? Can you keep them together? Which is what science has recently discovered, that it in fact is a bound cluster. That means the gravity within the system is equal to the force that wants to separate them, so it stays together. In contrast, loose the cords of Orion. The systems in the belt of Orion are flying apart at breathtaking speed. Fascinating that should be in Job 38, verse 31. But the general principle is that things seem to be moving apart and moving round and round, sometimes in intricate patterns. But the problem is the globular clusters and the concentration of the matter in the universe, which should be uniformly distributed, but is not. Even Einstein recognized this problem and came up eventually with ideas to counter it. But they're theoretical and not practical solutions. So this law of the conservation of angular momentum, what does it mean? Everything in the universe is spinning. Planets, stars, galaxies. It would take an enormous amount of energy to start a planet spinning, something that's called inertia. So advocates of the Big Bang Theory propose that the singularity, that little dot, blew up and the Big Bang was spinning before it exploded. Thus, everything within it was spinning as it flung out. But now there's a problem. However, some galaxies, some planets, for example, Venus, Uranus, Pluto, many moons are spinning backwards. That's called retrograde motion. It's going the wrong way around. Some moons even have a retrograde orbit around the planet, going the wrong way. Some are going this way and some are going the other way. Jupiter, Saturn, Uranus, Neptune have moons orbiting in both directions. Now, this is a serious problem. Here's a galaxy called NGC 4622, which appears to be rotating in the opposite direction. The whole galaxy going the other way around. Now, this is another serious problem. What do you do with all these things that are going the wrong way around? Planets and moons and all of these things that are going the wrong way around. What do you do with them? Well, the problem is that you would have to say something stopped the spin and put it in the other way. That would have to be such a force that would probably shoot the whole planet apart, and you would have to do it all over the place, even within the same systems. A highly improbable event. So even that seems to violate the idea. There are many scientists who feel that there are many problems with the Big Bang. Here's an article in Nature which says the Big Bang is not yet dead, but is in the decline. And it also says that it implies that some of these findings imply an age of the universe much smaller than the known ages of the stars and the globular clusters of the galaxy. So as far as the Big Bang theory is concerned, the proponents for and against both have arguments, but at least we can say categorically that not everybody says categorically, yes, that's the way it happened. In fact, there are many that say it could never have happened that way. And that's only fair that we hear the other side of the story. And the exploration of space and what science has learnt in the last decades is just amazing and boggles the mind. Now, the story goes actually even further. From the Big Bang, you had an explosion. Originally, there was energy. Then a quark soup. These are subatomic particles. Eventually, the first atoms formed, although they never should have. They should have been destroyed by antimatter and matter coming together. And now you have hydrogen. The whole universe out there filled with hydrogen, perhaps a little bit of helium and some of the slightly bigger ones, but basically hydrogen. Now, what do we consist of? What elements are there in us? Everything, from carbon to every single ion that you can imagine, the whole periodic table, we have it. Now, where do all those come from? If we all evolved naturalistically, where do all these other particles come from? If there was a vast gas cloud, it's consisting just of the very lightest of the gases. Well, science teaches that these compounds must have formed out there, or else they couldn't be there today, right? So how did it happen? Well, they reason that the gas clouds started to coalesce upon each other, and eventually forces within the system contracting through gravity, the various elements in upon each other, until you had the formation of stars. And in the stars, you would have nuclear fusion, creating all the other components, and then those stars explode with a supernova and put all that new material into the space. And then that gathers again into new systems, and eventually you have all the elements that you need. There are major problems with that. How do you get a gas that is expanding in a vast universe of space to come together under forces of gravity, mind you, which we do not see operating at that level, forming a star? That's a major problem. And then to redefine it and eventually to have the raw materials to actually start an evolutionary process of naturalistic evolution until we can get the dawn of man. That's basically what is taught. So originally, there was just inorganic material. And this inorganic material gathered then on some planet, and on this planet of inorganic material, organic molecules formed spontaneously on this planet, and those organic molecules again came together fortuitously to form the molecules of life, and they in turn to form cells, and they in turn to form the other organisms on the planet. That's what we're taught. So basically, where does everything come from? Dust. Dust. And dust reconstructed itself through processes, naturalistic processes, to eventually form everything that we see today. So basically, you come from a rock. That's what is taught. That's what one has to believe. And one has to ask oneself the question, is this feasible? That dust eventually formed life, and life eventually formed the complex organisms and structures that we see in the world today. Is that feasible, all by itself, driven by a process which required natural selection? We'll be dealing with all of these issues. Now, science further teaches that once this process had started, then on our own planet, through various ages, which are characterized in millions of years, life came into existence and the evolution of macroorganisms, that's everything that creeps and crawls and does whatever it does, took place in the last 600 million years. And there's a huge time scale which is thrust at us and say, there it is, you do with it whatever you deem fit. And then we are taught that since this early dawn of the macroorganisms, I'm not talking about the prebiotic world, the world can be divided basically into time zones, which geology has basically termed the Paleozoic, the Mesozoic, and the Cenozoic, and that in that time, organisms evolved, and that today we can actually see the record of this evolution in the rocks. That's the science of paleontology. The science of geology concerns itself with how the matter was formulated and formed on this earth, how it came into its present position, and how everything came to be as old and as distributed as it is today. Now, is this true? Do we have such a paleontological record? The answer is yes. Do we have such a geological record? Well, the answer is yes and no. Because nowhere in the world do we have such a complete record. We have a fragment here, we have a fragment there. So basically what we see on the left is a theory which science has put together. It is not based on a definite column that we can go and look at in any place of the world. So tonight I want to look at the basic assumptions of geology. Just the basic assumptions. Tomorrow night we will be dealing with the living organisms. We'll be looking at how the organisms evolved, how the world tells us they came into being, and whether this is in line with what we see or whether it is not. These are very important questions so that people can make informed choices. Let's first have a look at some of the questions of age. Radiometric dating. Radiometric dating is a technique that is used to tell us how old objects are. And basically, it's not a very complex system, and it works very well. You can do it in a laboratory. There are ways of exactly determining the ratios of certain isotopes to each other, and this information is used to tell us how old things are. But the problem is, you have to make certain assumptions. And let's just run through them. The first assumption you have to make is that the rate of decay and half-lives have remained constant over time. Okay, basic principle. You have a specific rock. In that rock, you have elements which decay by radioactive decay. For example, uranium-lead dating. You have uranium. You have a certain time in which it decays to a certain isotope of lead, and after X millions of years, you have half the amount of uranium as you had before. Over the next same time period, again, you have, another loss of half the material. We call that a half-life. And so you can determine, by determining the ratio of the one to the other, how long this process has been going on. But you would have to know that the rate of decay and the half-lives have remained constant over time. And there is evidence that it has, and there is evidence that it has not. So both sides of the story can be found in the literature. The second principle is a very simple one. If I want to know how old something is, then I must be sure that the clock was set to 0 when the material was formed. All right, that's very simple. How do I know how old any one of you are? What basically do I have to know if I want to know how old any of you are? I must know when you were born. Isn't that right? I must know when you were born. So if I have a birth date, well, then I can work it out. This individual is X number of years old. How old are you the second that you are born? 0. In fact, somebody stands there with a stopwatch, and the time you are born is registered, tick. And after 5 minutes, Daddy walks out with the child in his arms to show whoever's watching and says, my baby is how old? 5 minutes old. So I have to have a birthday. So now, if I want to know how old the rock is, how do I know when it was born? No, if I wasn't there to see it born, sometimes you can be there. If volcanic material comes out of the earth, you can see that it's born kind of now. You know what I mean? But rocks that are supposed to be ancient, I wasn't there, nobody was there. How do I know when they were born? I don't know when they were born. So I have to use a supposition. I have to say that when the rock was born, the clock was set to 0. Now the clock consists of one isotope changing into another. So I must assume that when the rock was born, only the parent isotope was there and none of the daughter isotope. That's 0 reset, isn't that right? Now, is that the case or is it not the case? The answer is that the literature abounds with cases where it is not the case. Where, for example, volcanic ejecta comes out of the rock right now in Hawaii or in New Zealand, and you measure it, send it to the laboratory for dating, and it can measure anything from a few million to hundreds of millions of years old. Now, if that is the case, then is the clock set to 0, yes or no? Obviously not. And if the clock is not set to 0, then how much faith can I have in the dating system? Here's another problem. We are dealing with a closed system. Obviously. If I'm going to determine ratios of one to another, it must be a closed system. Can you imagine, here in the front, I have a timer, a sand timer. You know, like an egg timer? Imagine it standing in the front here. And I turn it, and all the sand is on top, and in the bottom I've got lines indicating the minutes. And after 1 minute, the sand has come down and filled it up to the first line, and I know 1 minute is gone. After another minute, the second line. After a third minute, the third line, etc. That's how the clock works. Now, what if there was a hole in my glass at the bottom? And as the sand came in, some of it escaped from the bottom. Would my clock be accurate, yes or no? No, it would not be accurate. Same with a rock. If I'm dealing with a rock and the elements inside that rock somehow were able to escape a hole in my clock, would I be able to use that sand in there as a time mechanism, yes or no? No. Question. Does lead, for example, dissolve in acid water, in rain? Yes or no? Absolutely. That's why we have heavy metal pollution in our rivers and in our lakes, right? So, if it rains and water falls on the rocks, and the rocks are porous and the water goes through, can I wash out some of the elements, yes or no? Obviously, yes. I mean, that's how mountains work. They soak up the water and they form huge reservoirs of water because they contain them and soak them up like a sponge. So here are mechanisms of taking out the isotopes. So basically, I cannot guarantee that the decay has been the same. I cannot guarantee that the clock was set to 0 when the material was formed, because it's not set to 0 even today. And I'm not dealing with a closed system. So how good is my clock? Frankly, my clock is useless. Totally useless. The scientific method of determining one isotope relative to the other may be perfect. That may be so, but it means nothing in the light of these points. So when somebody tells me, how old is something? Then how old can it be? As old as you would like it to be. You see, when Einstein couldn't figure out, or the world couldn't figure out, what was happening in terms of light and the movement of light whether an object was moving towards you or an object was moving away from you, that the speed of light remained the same, although it shouldn't have. It doesn't make any sense. Obviously, if two objects are going to move towards each other, they're going to get there sooner than when they're moving away from each other, right or not? So, what was his solution? He came up with a theory which he called relativity. That's it. So that's the solution to a big problem in science. It's nice, but it's just a word. We don't have to go into all the details. So if somebody asks me, how old is this rock? I say, it's relative. Relative to what? Relative to my paradigm. Relative to my way of thinking. If I believe this rock is young, there is nothing that you can do to prove that it is not. And if you want to believe that rock is very old, there's nothing that I can do to prove that it is not. So believe it if you want to, that it's billions of years old. Or believe it if you want to, that it's a few thousand years old. There is nothing that stops you from believing what you want to believe. Nothing. And no matter how much arm wrestling science does with you, to tell you that you must believe that it's old because that is their paradigm, tell them it's relative. You can believe whatever you want to believe. There is no evidence, impelling evidence to force you to change your mind. You don't have to. Having got that out of the way, and please, I'm not saying you can't believe what you want to believe. I'm saying you have freedom of choice to believe what you want to now. That's all. That's all. So I'm not running anyone down. Now, let's have a look at these rocks. Science teaches that each one of the rock layers that we find in the geological column, which is something that doesn't exist anywhere on this planet in toto, each one of these once represented a time gone by, sometime in the distant past, when each one of those was the surface of the earth, and life was enacted on each one of these very much like it is enacted today. So today we have cycles of rain, we have cycles of weather change, we have all these cycles, we have cycles of erosion, we have cycles of deposition. Everything that happened in the past is the same as what happened today. So obviously, it is logical to say that the bottom layers will be the ones that were there first. Then came the next stage, then the next stage, then the next stage, then the next stage. Or we could say that this is a layer of material, then another layer of material, then another layer of material, and then another layer of material. See the difference? It's not very big, except for what? Except that science attaches great time to each layer. Does that make sense? So science says each layer represents a huge block of time. So when you take a layer away, what are you taking away? A huge block of time. Whereas if you say each layer is just one layer of mud on top of the next layer of mud, and you take one away, all you are taking away is a layer of mud. There's a difference in the thinking there. So let's think about that. So science teaches, okay, the first layer is at the bottom, that's the oldest one, then came the next one, then came the next one, then the next one, then the next one. That's called superposition, one on top of the other. It's very logical, makes perfect sense. And then we are told that the oldest layers have organisms such as these, so that's obviously what lived then. And if you go a little bit higher into that layer over there, the Ordovician, then you had creatures like this. If you go a little bit higher, you come to the Silurian, you have creatures like this. Go a little bit higher to the Devonian, well, you have fishes and all kinds of things. If you go a little bit higher, you come to the Permian, you have the first land plants and all these interesting things. And then these huge trees, then you come to the Triassic and the Jurassic and the Cretaceous, and you have these wonderful dinosaurs and all these interesting creatures. Then you go a little bit higher, then you come to the Cenozoic, and then you get all the mammals. And that's how evolution happened. So you started with these marine organisms, and then you went up through the fishes, eventually to the frogs and the reptiles, and etc. Now, we're not going to deal with the animals tonight. We'll deal with them tomorrow. Let's just look at the rocks tonight. Now, rocks are never as interesting as animals. So tomorrow obviously will be more interesting. We'll look at dinosaurs and evolution of creatures and all of these things. But rocks are what you have to walk on, right? So they're important. If you were not on a rock, you'd be in trouble. Now the Bible has a totally different story. The Bible tells us that at some stage there was a flood. The Bible says that this flood lasted 1 year, 17 days. That's kind of strange. Most people think flood, it rained 40 days, 40 nights, and it was all over. No. That's not what the Bible says. The Bible says it rained 40 days and 40 nights. The Bible says the waters of the great deep broke forth, and the waters rose for some 5 months. Then they started to decline, and after 1 year and 17 days, Noah could leave the ark. Now that is decried a fairy tale today. A very strange little story, an allegorism, just to keep people happy, and makes a nice children's story. But in any case, that's what the Bible teaches. And that it took 1 year, 17 days, high in the mountains of Ararat, for Noah to actually leave the ark. You see, it says, he was so old when he entered, he was so old when this happened, he was so old when he sent out the ravens and the doves, and he was so old when he left the ark. So you can work it out, how long it was. And it's 1 year, 17 days, with major activities happening during this event. And what's also very interesting is that if you look at the geological column, what you see is a lot of mud. And mud happens in what? Happens in water. So if you go to the Grand Canyon, for example, and you look at the various layers, then yes, what you see is one layer on top of the other. Now remember what science teaches. That was once the surface of the earth, followed by that one, followed by that one, followed by the next one, etc., all the way along. When you look at those layers, can you see that they're all nice and flat, and that the contacts between them are perfectly flat? You see that? Absolutely flat. It's like the world was, and then came another world time period and went, then came another world time period and everything very flat. Huge flat layers, one on top of the other. So there you can see them very nicely. 1, 2, 3, 4, 5, etc. They're all nice and flat. And the contacts between them are very flat. Now remember what science teaches. Each one of them was what? Once the surface of the earth. Okay, let's go down into the Grand Canyon. And you'll come to something which they've called an unconformity. This is what the geologists have placed there. And an unconformity is a very interesting thing. Here is where it is, they say. What is an unconformity? Well, I've told you before, nowhere do you find the whole column in one place. So some places there are pieces missing. And here's one of those. So here are 2 ages, but a rock layer that should be there here in the Grand Canyon is absent. Now, there are 2 possibilities. The mud is missing, or 2, the time is missing. Are you with me? Now, if you say the time is missing, then they'll say, whoa, here's a problem. Time just doesn't go away. So obviously the time must have been there. So science teaches, this is what happened. Well, obviously what happened here is the layers formed, and because time is an essence, the missing layers must have formed, because that time was there, and then there must have been some rapid erosion here, and they were rubbed out. Away with them, and another layer deposited on top, and voila, we have 2 layers with a piece in the middle missing. No patty between the 2 burger rolls. Nothing. Just gone. Now, that's fascinating. That's what science teaches. What took it away? What's the only thing that took it away? Erosion. Right, let's have a look at them. Here they are. There's a time period missing in the Grand Canyon, and that is estimated to be some 100 million years gone. Here's another layer missing, some 30 million years gone. Now let me just put that in perspective for you. If we take the present erosion rates on this planet, And we measure how much of the soil is being washed into the oceans every single day. Well, you live here next to the Mississippi River. Is the Mississippi spanking crystal clear, yes or no? No. Why not? Because it's obviously taking material down into the sea, right? That's whatever it erodes away and it ends up in the ocean. So that's where it gets to end up. Now, the same must have happened here. There must have been a period of erosion, they say, and that took away the layer. Now, how much could be taken away in 100 million years? Well, did you know that at the present rate of erosions, if we take the lowest level for the United States, which is about 6 centimeters of Earth's surface every 1,000 years, the highest being in the Himalayas, some 2 meters gone every 1,000 years, then it would take just 10.2 million years to wash away the entire continent into the ocean using the lowest level. So 100 million years, that's enough to wash the entire continents, present continents, into the oceans at least 9 times over. That's quite extraordinary. Okay, here you have these flat layers with these contacts missing in between. 12 million years missing between those layers over there. 12 million years. That's enough to wash the entire continent into the ocean once over. And it's a huge area stretching over all of that. And between the 2 layers, this one and the one underneath it, just nothing. Gone. Although we have evidence of a lot of water rushing, that should have left some erosion. Look at these contacts. Flat. Time missing. Time missing. Absolutely flat. Here you have 20 million years missing between this light one and this dark one. 20 million years gone. Flat. What happened? Now, if you have erosion, isn't this what happens? Yes or no? Doesn't erosion make valleys and ravines and things like that? Here are 3 layers taken in Africa on one of the mountain ranges there, the Cedarburg, very beautiful area. And look at them. There's one layer, there's another layer, and there's another layer on top. Let me give you another picture. There, on the left. Look at them carefully. A layer at the bottom. Now remember, what does science teach? This was once the surface of the earth. There's the contact between them. There's the next one. There's the contact between them. Now, millions of years later, there's the next one. That's now on top. So that's getting some erosion exposure. Can you see how nice and flat it is? Is it flat, yes or no? No. It looks like this. Up, down, down, whatever. Why? Because erosion washes it out like that. So now if I put another layer on top, let's say all this went under the ocean and I put another layer on top, would the contact be zip, or would it be yep, 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 yep? What would it be? What do you say? It certainly wouldn't look like that. So do you think it's possible that that was never really the surface of the earth for a very long period of time? And that before you could say, Jack Robinson, the next layer was on top? Is it possible? But what would that do to the evolution theory? What would it do? It would create a great problem, because these things happened over millions and millions of years with the same principles applying today, applying to the past. There will be a problem. Look at this. Here's a layer, 1, 2, 3. Everything in between is gone. Where is it? Well, it's been eroded away, obviously. All right, so if I put new layers on top, I certainly shouldn't get flat contacts, shouldn't look like that. Erosion will have it look like that, right or wrong? And if I put a layer on top, it should look like that, right or wrong? But it doesn't, it looks like this. All right, now let's think about this. Let's say this is the Grand Canyon, and the black is one layer, and the red is another layer, but I know there should be a yellow because it was found in another area. But it's not there in the Grand Canyon. So what does science teach? It was washed away by erosion. Is that right? and therefore millions of years of time cannot be found there. But the contact is absolutely flat, and it shouldn't. It should look like that. So now, here's another possibility. In actual fact, this wasn't time at all. These are layers of mud. There's one layer of mud, a missing layer of mud, and a red layer of mud. Whereas here we have a black, a yellow, and a red layer. Let me explain this. I have 3 buckets of mud here in the front. One contains black mud, the other one yellow mud, and the other one red mud. Now, I take this huge bucket that I have of black mud, and I go, whoosh, and I spread it all over this hall. And then I take my bucket of yellow mud, which happens to be a small bucket of mud, and I go, whoosh, and I just spread the front here with my mud. And then I take another big bucket of red mud, and I go, whoosh, and I spread it over the hole. Now I have, in the front here, eventually when it dries, I make a cut. How many layers have I got? 3. In the back there, I make a cut. How many layers have I got? 2. Aha. So in the back there, obviously what happened is millions of years of erosion took the middle layer away, right? Right? Or would you perhaps agree with me, I didn't have enough mud to get to the back? You see the difference in the philosophy? The one requires time, the other one talks about mud. Now, which one is right? The Bible says there was a flood, a worldwide flood. That's what the Bible says. Now, if that is true, you would expect a lot of mud on earth. And do we find a lot of mud on earth? Yes. Everything is mud. Marine sediments here on this earth. Where should they be? In the bottom of the ocean. There's not enough there to account for any of this time that has gone by. It's all sitting on land, which is all kind of upside down. Now, here are some scientific publications. 20 million years of weathering and erosion under varied conditions. And then he says, the survival of these paleoforms is in some degree an embarrassment to all the commonly accepted models of landscape development. Here's a scientist that says, you know, we have a problem. All of these mud layers are there, and erosion is taking place all the time, and look at what we have. Everything is still there. Actually, it should be gone several times over. Why is it still there? So we will be looking at this issue in the next section. For example, the outcrops were excellent, but even the closest inspection failed to turn up the precise position of the 15 million year gap. Why is there a gap and I cannot see it? These are questions that need answering, and we'll see them in a moment. In our previous section, we talked about these incredible flat layers and the gaps missing between the rocks. And now we want to look at how these form. For example, here's another few publications where they talk about immense and incredibly flat areas of the world in the past. Here is a formation where we see coal seams in rock. Notice that the coal seams are also incredibly flat. Now, this is not consistent with what science teaches, that coal formed by natural processes, forests being covered in debris and eventually forming the various coal seams. Here they are, incredibly flat. And we have wonderful preservation of plant materials in the rocks. Here is a beautiful coal seam, and we'll be talking about coal some more later on. But again, notice that they are in these flat seams. Everything incredibly flat. This is not something you would expect to happen under naturalistic processes. Here, for example, trees upside down in coal fields. Another important discovery is that there doesn't seem to be any evidence of subaerial exposure. Traces of deep leaching, scour, channeling, residual gravels tend to be lacking, even if the underlying rocks are soft material like Cherty limestone. So, if there was erosion between the layers because they were the surface of the earth, why don't we see it? There's no evidence of it. It's just doesn't make sense. This is what we call a turbidite. Now let's have a look at an alternative model. This is what is an underwater mud flow. When water is muddy, we say it's turbid water. It's muddy. Now, a turbidity current is an underwater mud flow. Now, in 1929, there was an earthquake in North America, and a piece of the continental shelf broke loose, and it roared under the ocean, breaking cables as it went, so they knew exactly how fast this mud was going. It was just going at a tremendous pace. After 3 hours and 3 minutes, it was 300 miles out to sea. That means that this mud was traveling at a speed under the water of 100 miles an hour. Now imagine if you were a little creepy crawly, or a fish swimming lazily at the bottom of the ocean, and a wall of mud as thick as this wall over here comes roaring towards you at 100 miles an hour. What would happen to you? You would just be fossilized in an instant, right? Now this is what happened. Notice that we have a model over here. Imagine this is the surface of the earth, largely extended. There's no mountain on scale that would be this high. And everything's underwater, and now there's an earthquake over here, and some mud is beginning to flow. Let's see what would happen. There it flows. Watch how it comes over the hills, into the valleys, over the top. And then it's going to settle down. And notice what it does. It's very interesting. It fills in the valleys while forming a layer over the hills. And this is soft mud, soft mud. Now we're going to put another layer on top of this while this is still soft mud. We're not going to stick around for a few million years waiting for this to turn into stone, okay? We're going to do it right now. While this is still mud, we'll have another earthquake in another place with a different color mud, and boom, there it goes. Watch how it comes around the corner, swirls clockwise. Do you see that? Goes down the hill, up the other side, and does the same thing. Now, do you think it's possible that you could whip some of the bottom mud into the top mud layer when it goes around the corner like that? Do you think it's possible? Possibly, yeah. Here's another one. Look, wham! Take some of the bottom layer, put it in the top, maybe. And then you settle down. And we're not going to wait a million years. We'll just let it settle. And then put another one on top. Notice the valleys are getting fuller and fuller and fuller. By the way, that's what it looks like at the bottom of the column. Between the Cambrian and the Precambrian. That's what it looks like. Another layer. And another. And another. And now it's getting pretty flat. And now they're just rushing along nicely, one on top of the other. And then we have a closer look. What do you see? You see one layer on top of each other, and what are the contacts like? What's the contacts like? Flat. And especially on top, everything is flat. And can you see that here and there, for example, there's a little bit of mixing of the bottom layer into the top layer. Okay, if we go a little bit closer, notice what else we'll see. All right. If you look carefully, you will see that in this layer, from there to there, the coarser material, the heavier stuff, is at the bottom. Why? Because it's heavy and it settles out. And the finer material is at the top, because it's lighter. and it takes longer to settle. So this thing is graded coarse to fine, which is what happens in water. Now, if this layer had to form over millions of years with then a rain and then a drought and then a rain and then a drought and all these things happening, would the whole thing be jumbled up or would it be graded coarse to fine? It would be jumbled up. If it's graded coarse to fine from the bottom to the top, what does that mean? That this layer formed how? Boom. Catastrophically. All right? So if we go into nature and we have a look at them, here we are in the Swiss Alps, hundreds of these layers, one on top of the other. So it's just one after the other. Here we have some in Texas, and they've been lifted up. And you can drive to any of these areas in your country, you'll see beautiful examples. They were, of course, first flat, then they were lifted up later. These are all turbidites. How do we know? Because they're graded coarse to fine. Here are huge ones, big ones, showing tremendous activity. Here's another one. Notice the coarse material is at the bottom, then it gets finer, and then you have the fine mud over there. There are even some ripple marks saying that this happened underwater. And there's the next one, the coarse material to the fine material. Here's one in Australia. This one is in New Zealand, sorry. There you have the coarse material at the bottom. You'll see the pebbly, grainy stuff, the water lines, and then the finer stuff, and the next one starting on top. So how did they form? Slowly or quickly? They had to form just like that. These are mud layers that form just like that. Now, if you go to the Grand Canyon, you'll find a fascinating thing. From the bottom to the top, the whole canyon is graded coarse to fine. Wow. That means that the whole thing must have happened in a very short period of time. Now, the scientists will tell you, now, whoa, hold it a second. There are obvious regions in the geological column where we can say that this was a desert time period. How are you going to fit that into this watery situation? And they will cite areas like this in Zion National Park, for example. This layer, they claim, was a period of desert. And this over here is a desert dune. There's a problem here, because desert dunes never got to be this big, because they just cannot be that big in air. But underwater they can. And so they studied these in detail, and looking at the way in which it is laid down and how it is formed, they've come to the conclusion that after all, they were formed in water. So what happened? Let's assume you have a continent, and the mountains that are here today in the world didn't exist. Didn't exist. So it looked different, and you had huge inland seas and you had an ocean basin. And then something happened, and the whole continent was pushed under the sea. That means the sea would rush onto the land, and all the sediments in the sea would go onto the land. Then you would have the sediments of the ocean mixed with freshwater sediments here on the land. And then you do the reverse. You lift up the continents again, folding takes place, the mountain ranges form, and the new ocean basin forms. And the sediment that was in the ocean is now on top of the land, and you can see it in the mountain ranges and all over the place. And that's what it looks like. The sediment is on the land instead of in the ocean. Where should it be if the oceans have been around for hundreds of millions of years? Where should the sediment be? The bottom of the ocean. It's not there. It's on land. Well, that's very strange. Let's have a look at these layers. Here are two layers in the Grand Canyon. The one is called Coconino Sandstone. The other one is called the Hermit Shale. You can tell them nicely apart. They've got two different colors. And you can see some interesting structures. Boom, there's one. It's called the flame. Here's the one layer. There's the other layer. And here there's obvious mixing. Can you see that this one over here is as if it were whipped into the top layer? Can you see that? So something came rolling along and whipped up some of the bottom into the top and mixed them. Now, if this layer over here at the bottom were millions of years older than that layer, would that have happened, yes or no? Never. This is a geological nightmare, because this cannot be explained other than by catastrophism in water. Or could I depress a top layer into a bottom one, squelching it, not breaking it, going if the bottom layer weren't soft? Impossible. Could I fold mountain ranges like this or like this? Could I just take the layers and go like a bunch of layers of dough in a whatever donutty thing? Could I just go do that? No, unless the layers were soft. Now remember, science says each layer was the surface of the earth. Each layer constitutes millions of years turned into rock. How am I going to bend this without shattering it into millions of pieces? Impossible, unless the layers were soft. So how does science solve this problem? I said, well, what must have happened is they were rock, but then there came a time of continental depression and it went down into the heat of the earth, and there it became molten. Then it was lifted up and folded. Hello, here's a problem. Then there should be evidence of this heat upon the rock. But most of these rocks are sediments, no evidence of any heat, no volcanism, just water, mud, and fossils. No heat. And they're all folded like that. So it must have been soft. Here's another interesting one. Here's a finger sticking through another layer of mud. Obviously this finger is hard, this layer is soft, so this erodes away, and there stands this finger. Ding! What's it doing there? Where's it come from? So if you look at the layers, this is in Kodachrome Basin, also here in the United States, different layers. There they are. And the bottom one over here somehow had columns shoot up through the other layers and then solidify there. So this one over here shot up through this one, through that one, into that one, and there it sits. And that one shot up from that one through the others, and there it sits. Now erosion takes place, washes it away, and there stands a finger. Bing. Now this is very intriguing. Imagine you have 2 layers of glass, tabletop glass, Imagine you have 2 layers. And now you have a tube of toothpaste, and you go to the glass, and you take your tube of toothpaste under the glass, and you go, squeeze! What will happen to your toothpaste? It'll go, peek! And if you look at the top, you'll see one big flat patch, right? Because the toothpaste cannot go through the glass, it's solid. Now, the same with these rock sheets. If I'm going to say the bottom layer is getting soft, and I go, squeeze, and go, how can it go through the other layers if they are solid rock? What should the mud do? It should go, but it didn't. It went, through all of them. What does that tell you? It tells you that when this happened, they were all soft. So they were laid down, then there was an earthquake, put pressure on the layers, and it went chop, 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 chop. And they shot columns through, and then they got stuck, and then they dried, and they formed this. And that's how you get that. Only if they were all soft. So there they are, standing there as though they should have been there. If you look here at the Grand Canyon, that's another interesting area. The Grand Canyon goes through an uplifted area, and there is the canyon. Now, rivers don't flow over hills. Rivers flow down here in valleys, but here it went through the top. So how did that happen? How did it happen that a river stayed up there and went over the mountain? Cannot happen. So something must have happened to form a rip, and the water must have rushed through, and the layers that we have are indicative of a major flood catastrophe. So looking at the Grand Canyon, what washed this out? This little river flowing over a hill? Doesn't happen. All these layers, we've seen that they must have been deposited quickly. This massive amount of material washed away. Was it rapid or was it slow? The Zion Canyon, look at that. A sheer canyon. Who's ever walked up Zion Canyon? It's great, eh? It's magnificent. You walk up that canyon and you just got to be careful that floods don't come. And by the end, you can touch both sides and go up the canyon. Wow, it's magnificent. You guys should do it. And you look at those canyons and you think, wow, what happened? Was that rapid or was it slow? Well, here you're going to Africa. This is when the fledgling state Namibia was formed. And we're up there in a region of the Fish River Canyon. Beautiful erosion features, ripple marks. Again, water features everywhere. And there is this canyon. Look at it. Nice V-shaped canyon. going round the corner. It's not as impressive as the Grand Canyon, but not everybody can keep up with you guys. And this is the Orange River Canyon. Here comes the river, makes this huge waterfall, and then flows in this beautiful canyon. Can you see the canyon is V-shaped? Can you see that? V-shaped canyon. So now we've seen the Fish River Canyon is a V-shaped canyon. This canyon is a V-shaped canyon. The other canyons in the world, V-shaped canyons. You've got to be careful when you go walking there, because this critter here is extremely dangerous. That's a yellow cobra. And some beautiful erosional features visible over here. Plus this. This is a water whirl. There's another one. So here something went, took it out. When it was soft mud or something else happened, science will tell you, what happened here was the water flowed and there was a stone in there and went round and round and went grind and made a hole. So there's a nice round hole. Some of them you can sit in like that. Some of them, like this one, are high up in a mountain. Did the water flow up there? That there are these round holes? Or is this evidence of a recent flood? Here is the Colorado River. Here you can see the goosenecks. Notice that it is V-shaped. Again, there you can see it beautifully V-shaped. Now, a scientist published in the journal Science an article where he said, we have a problem. Because if it is V-shaped, then it had to be rapid. It could not have been slow, because slow undercuts and deposits. So all of these canyons must have occurred instantaneously, rapidly. So that was rapid, that was slow. So what washed it out? What happened? This is another canyon that formed instantly, Canap Creek, and you can see it's also V-shaped. That's a recent one that would washed out in modern times. This is Bryce Canyon. Who's been to Bryce Canyon? Wow, you guys must go there. This is a beautiful place. So you get up to this mountainous region, and you see this beautiful washed out area. Notice this massive washout. There's a human being as a scale. It's fascinating to see what happened over here. Everything in between is just gone, washed away. Everything in between. Erosion has eradicated it, leaving these magnificent monuments to some water activity. This is Monument Valley. Notice these mounds that stand in this valley. Now, once upon a time, these were all flat sheets, one on top of the other, and what has washed everything in between away? What does science say? Millions of years of erosion. But in actual fact, when you look at them, is it possible that it could have been rapid erosion rather than millions of years? There are the monuments, there they are. Everything in between is gone, and these stubbornly remain behind. Look at those two, standing side by side, like two cooling towers at some factory. Amazing. There they stand. Everything else in between is gone. Millions of years of erosion has taken it away, but these two are stubborn as goats. There they stand. We will not go with the rest. Does that make any sense? Or those are the Navajo twins, and everything else in between is gone. I'm going to take you to an area in Africa, and this is in Basotho land. And here is an interesting feature. This happened in one rainstorm. Notice that the rainwater came and washed away all the material, leaving a mound there, a mound there, a mound there, another one there, another one there, another one there, a couple over there, and a range over here. And that is what happened in one rainstorm. Now, why are these still there and everything else is gone? Imagine this. The water's coming along, washing away the soil. It's busy digging these channels, taking away the mud, and then all of a sudden the rain stops, and what happens? The water's gone. And before everything could be washed away, it dries out, and leaves these mounds. Now, isn't that exactly what Monument Valley looks like? Yes or no? It's exactly what it looks like on a small scale. There's a little canyon that formed in just a rainstorm. There's another one. Notice the V shape, exactly the same. This is a beautiful area. This is the Cedarberg, and here the mountain is cut into columns. You can literally get into one of those columns over there and walk through the mountain. Spectacular. When you get in there, it's like a cathedral with huge arches hanging over you like this, and you can walk in this area under these arches, and there you can see the layers of mud. 1, 2, huge layers deposited, one on top of the other, with these flat surfaces in between. And as you look down these slits, you can see there's a person walking. You can see right through them, and you literally walk up into this mountain. What washed that away? There's no river flowing there today. Either millions of years have taken away this area, or this happened rapidly, and this is a relic. Now, also in these mountains, you have this feature. Now, this is the other way around. There you obviously had the slits going from the top to the bottom, but here you have something totally different. If you look carefully, you can see that this mountain is standing on pillars. Can you see that? And there as well. The mountain is literally standing on pillars. There's a closer shot. So basically what you're doing over here is you're not walking in a slit on top of the mountain. You are now walking under the mountain. You're walking through a chapel of pillars. It's called Town Hall because it's got all these pillars. Now, this is weird. There's no river or anything there. What washed that out? How did this happen? That you have these huge mountain blocks standing on pillars. And everything in between is gone. And now you can walk through the mountain. Well, imagine this. Imagine you have these huge layers of mud, one on top of the other, covered in water, and suddenly this water drains off the land because the ocean basin is formed and the continent is lifted up. And this huge body of water just rips channels. And as the basins lower, the water level does what? Drops dramatically. So mounds of mud come up above the water level as the water level rushes down. And the water flows fast at the bottom, so fast that it starts doing what to these mounds? Undercutting them, washing out channels in between, underneath. Eventually, channels all the way through, and you have all these pillars and huge blocks of mud sitting on top of them. And then before everything is washed away and the whole lot collapses, what happens? The water is gone. And then it dries, and you have a whole mountain standing on pillars. So if you look over the edge where this water would have flowed, you see huge blocks of rock standing like this. But notice this. The erosion is at the bottom over here. There's no river flowing here. The erosion is at the bottom. It is as if something washed over the edge and was washing away here with lowering water levels, rushing through there, washing out the underneath, and it would have washed it all away, but then what happened? The water was gone, and there it stood. And that is how we can explain the features such as this, where you have these relics and everything in between is gone. This is how we can explain the amazing rock structures that you find in Zimbabwe, for example. All right, so this is how we explain these wonderful features where you have these rocks that seem to be balancing one on top of the other, and you wonder, how do they get there? But if this was actually a relic of huge sheets that were there, everything washed away, but before all of this could collapse, the water was gone, well, that would explain it. That would explain Ayers Rock in Australia. And now there's only one problem left. Science says that all of this is fair and well, but there's a problem. Surely it would take millions of years for these layers to form solid rock. Well, here's something interesting. We have a ceramic pot over here and a bottle encased in solid stone, and they come from the HMS Birkenhead, which sank off Danger Point in 1852. So basically you have two choices. Either this bottle is millions of years old, or this rock is not millions of years old. Now we know how old it is, so we know it must have formed rapidly. Here you have a bell, that's a ship's bell, encased in solid rock. So you have to now either believe that the bell is millions of years old, or that the rock is not millions of years old. Stalactites and stalagmites. Who's been to a cave, a big cave somewhere in the States? What do they tell you? How old are these stalactites and stalagmites? They tell you they are millions of years old. Is that correct? Okay. Here's one that formed when water was pumped to this area, and it grew in front of their eyes because the water was rich in calcium carbonate, and here it formed. Here is one, or many of them, where you see two people standing down there. Those are miners. This is a mine that has been vacated for some 30 years, and these are the stalagmites and stalactites in this mine. So now you have to assume that this mine is millions of years old, or that these did not take so long to form. Which is it going to be? We know that this is a mine, and that this took 30 years, and that is what you see. In fact, I have a bridge that I travel under when I go to work in my home country. And under this bridge, there hangs this beautiful stalactite about so long. Every time I travel under that bridge, I wonder, wow, who constructed this millions of year old bridge over here? So a picture really does speak 1,000 words. There's one last hope, and that is gemstones. Surely they take a long time to form. This is malachite. Malachite is a semi-precious stone which we find in Africa. It's a ritual stone. It's used by the witch doctors, and it has magical connotations for them. It's a beautiful green stone, and it forms in Zaire, the former Congo, and there are mines there where these are dug out. Now they form in columns like this, so they're basically like stalactites and stalagmites, and they form when the right elements are in the rock. Now it's very expensive, and here is a piece that was sent to the United States from Africa, and it broke in transit. Now a piece like this, that's about 12 centimeters across, it's not very big. A piece like this will cost in the region of $26,000 US. This is expensive stuff. So now, when it broke, they sent it back. And now the dealer had it and called me and says, I have a disaster, come and look at this. So I went and had a look. And there was a wire, can you see it? Sticking out of the rock. And I said to the dealer, you know, we have a wire in here. This is very, very strange. Do you mind if I take your $26,000 rock and break off the next one? Literally burst into tears. Literally. That's a lot of money, you know. But we took it and we went, and guess what? What do you see in there? Well, let me go a little bit closer. What do you see down there? It's another wire. And if you look at the material, it's malachite. There is no crooking here. This is perfect malachite. So now you have an option. This wire over here tells you that wire has been around for millions and millions of years. Or there's another option. The miners might have discovered that if they put copper wires down and they let water run through the rock material, that this would act as a center for rapid formation, and the stone would form quickly. So I said to the dealer, wow, where do you get this stuff? He said, I got it in Zaire. I said, that's amazing. Can you get any more? He says, no, they're out. I said, well, that's a great opportunity. Phone them. Ask if you can order some more. And he said, but they have none. I said, well, ask how long it'll take before you can get some more. So he found them, and he asked them when he could get some more malachite. And they said they were all out. So he said, well, how long would it take before you could send me another assignment? And they said, well, how big do you want it? That's a fascinating question, don't you think? How big do you want it? What has size got to do with what you find in a mine? And so I said to him, same size. Yeah, same size. So he said, well, about 12 centimeters by 12 centimeters. And they were silent for a while, and they said, we could probably find those in about 3 months. So how long does it take for this rock to form? 3 months. So do we need millions and millions of years for all of these features? The Bible says in Romans 1 verse 20, for the invisible things of him from the creation of the world are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse. So basically, if you go and look out there, maybe you can see things which might tell you that maybe the Bible's not so wrong after all. That's the bottom line of this text. Now, we have looked at some of the features. We've looked at the time issue. We've looked at the cosmology. We've had a look at the planets and the stars and all the theories as to where everything came from in terms of all of these things. But what we haven't looked at in detail is whether this flood indeed was universal. That's a problem. You see, science is willing to look at some of the evidence that they find and say, okay, we're trapped. We admit it. There is a problem. But we will acknowledge only local catastrophes. We will say, yes, there is a possibility that that feature over there formed during a local catastrophe, and that one over there formed during a local catastrophe. But a universal flood, forget it. Why? Why is it imperative, and think about this, why is it imperative for science to deny a universal flood? Why? I'll tell you why. Because if there was a universal flood at some time in the not-so-distant past, and it destroyed all life on the planet, and then it was over, and you wanted to stay naturalistic, what would you have to do to evolution from that point onwards? You would have to start it all over again. Are you with me? So, it is impossible for modern science to conceive of a universal flood. Impossible. If there was one, big problem. Then the continuity of the geological record and all its fossils would be interrupted, cut off. And you'd have to start all over again. And that is inconceivable. So stick around for the next lecture while you take a short break, and then we'll look at the possibility of a universal flood versus science which says no universal flood. In fact, it may not conceive of a universal flood. That could be interesting. You stick around, because this is what your kids are being subjected to every single day in their schools, on their televisions, in the museums where they go to, and it is time you had a look at the other side of the story so that you can make an intelligent choice. Without two sides, no choice. All I'm saying is expose yourself so that you can either ridicule it or accept it according to your will. Thank you for listening.